Hello and welcome to the lecture on Schedule Development of ProTrain's Planning and Scheduling Professional (PSP) Certification Prep course. In this lecture, we will discuss details of the schedule development process. This lecture is aligned with AACE International's Planning and Scheduling Professional Certification requirements. Let us get started. Why scheduling is important. Scheduling is the process that puts the project work plan on timeline. Scheduling assures timely project completion. Scheduling is one of the tools used for monitoring and controlling projects to ensure the objectives of cost, quality, and time are met. Schedules provide the baseline against which progress is measured. Schedules are used to assess time impact of changes to the work scope. Effective project management involves coordinating activities such as planning, organizing, implementing, and controlling time and cost. Time control is usually achieved by preparing and using schedules to make the most efficient use of available time. Scheduling is an important and integral part of the overall planning effort, since the scheduling process forces people to quantify their effort in discrete terms and to place activities in proper relationship to each other. The planning and scheduling functions are usually performed iteratively in order to accomplish all required tasks within the specified time frames. Benefits of scheduling. Scheduling provides a basis for management of the work, improves communications, and facilitates coordination. Using a schedule improves the effective use of resources. The project schedule gives the user a baseline to monitor and control the work. Scheduling provides a way of contributing input during project execution concerning means, methods, techniques, sequences, or other conditions affecting the plan's outcome. Scheduling provides a means for obtaining feedback since the development and use is a team effort incorporating the ideas and objectives of those responsible for the work. Schedules are good motivational tools providing intended work plans to those having to perform the work and reporting progress against them. Schedules provide a baseline for measurement and a means for collecting and recording progress. Budgets, costs, and resources can be integrated into project schedule activities, providing a basis for measuring cost as well as time performance. Schedules may be used as a basis for payment applications supporting work completed. Critical path schedules are used and relied upon by courts for amending contract completion dates. When projects are faced with significant cost and time overruns, schedules are used as analytical tools to support assessments of labor efficiencies resulting from compression or extension of time, congested work areas, and disruption to planned work. This lecture covers the elements of schedule development process in comprehensive detail. After completing this lecture, we would be able to understand inputs of schedule development process, types of schedules, and elements of schedule development. The schedule development process can be further subdivided into inputs and data required for schedule development and creating schedule subprocesses. The key input and data required for schedule development are: define schedule scope, break down structure relationships, schedule specification, feedback from stakeholders, cost estimate model. Similarly, the elements of the schedule creation subprocess are: types of schedule, activities, durations, relationships, constraints and calendars, cost and resource loading, cost and resource loading, milestones, Schedule quality analysis and compliance review. Schedule basis documentation. This lecture covers each schedule development process in considerable detail. Let's get going. As discussed a slide before, schedule development inputs are: schedule scope, breakdown structure and relationships, schedule specification, feedback from stakeholders, cost estimate model. Let us discuss each of them in detail, starting from schedule scope. The first step in schedule development is to decide the schedule scope. At this stage, we identify the scope for the schedule model, as well as the components of the schedule model. Following are the key items that define schedule scope. Scheduling tools requirements. The types or levels of schedule to be developed. Deliverables, milestones, timing, phasing, sequencing requirements, resources and interface points. Acceptable scheduling mechanics reporting details. The contract requirements and the schedule specification may dictate the schedule scope. A well-developed and managed WBS, OBS and CBS are critical aspects to developing and managing the project schedule. The WBS and OBS assist the project team in defining the work packages and schedule levels. The CBS is used for tracking, reporting, and controlling costs. Coding technique is an important item in managing breakdown structure and relationships. The purpose of a scheduling specification is to identify minimum requirements for key milestones and overall contract duration, required phasing and sequencing, contractor's plan, means and methods, cost and resource loading and reporting, subcontractor and supplier integration, plan and schedule basis documentation, owner and client requirements such as goals and objectives, ability to monitor the contractor, and control required when progress fails to meet contractual milestones and requirements. Schedule types and levels to be used and maintained. Reporting requirements, levels, frequencies, and formats. Scheduling software programs that are allowed, preferred, or required. The schedule specification also states the planning and scheduling requirements and their purposes. It defines level of detail required, reporting periods and capabilities, minimum and mandatory scheduling tools, initial schedule development, submission, phasing and milestones, changes, claims and disputes, scheduler experience and qualifications, and other requirements that the owner-client deems appropriate for the specific project. The schedule specification defines who is responsible to prepare, maintain, and approve the schedule, as well as any required processes for these actions. The schedule specification may define sequencing, contract limitations, site restrictions, resource restrictions, weather constraints and assumptions, identification of and dealing with scope changes, submittal requirements, and any other requirements. It is important that the scheduler understands the constraints and limitations of the applied scheduling software when developing the project schedule. Feedback from stakeholders. The input of the stakeholders, internal and external, is required during the development and maintenance of the schedule. The project team must understand the perspective of each stakeholder, so that varying issues may be appropriately addressed and resolved. It is important to get stakeholder buy-in for the schedule. If they do not buy into the schedule, there may be no sense of ownership. Disagreements will increase, maybe resulting in delays or impacts. The scheduler or the team responsible for developing the schedule must identify stakeholder input and how it must be accounted for in schedule development and maintenance, and understand when and how the various stakeholders influence the project over the timeline of development, construction, startup, testing, and transfer. Who are the stakeholders? Stakeholders are individuals and organizations who are actively involved in the project, or whose interests may be positively or negatively affected as a result of project execution or successful project completion. Stakeholders can be divided into two categories of internal and external stakeholders. External stakeholders are owner, local political and community interests, permitting and code enforcing entities, owners, users, and customers. Whereas internal stakeholders are prime contractor and project management contractor, principal subcontractors, second tier of subcontractors, suppliers, installers, startup, testing, and compliance support personnel. Cost estimate model. The cost estimate is a key building block for defining and developing the baseline schedule model. The cost estimate identifies and defines quantities and resources within the WBS, OBS, CBS that will be included in the schedule model. This allows for monitoring and controlling of the work in a consistent and reportable manner. The cost and resource-loaded schedule model forms a baseline for cash flow, earned value management, and resource management and change management purposes. The cost estimate model assists in developing and identifying the risks to meet the schedule requirements. The scheduler or the team responsible for schedule development should understand how to take the cost estimate using the WBS and develop the cost-loaded baseline schedule. The project team must fully understand how all aspects of the cost estimate are incorporated into the cost-loaded baseline schedule and form the basis for the initial project cash flow and resource allocations. The cost estimate identifies the initial risk that is associated with the project timeframe and will be incorporated into the baseline schedule. Such risks are primarily related to time-dependent cost-related risks, such as the availability of resources, cost escalation, etc. We have discussed various scheduling methods in earlier lectures. Now let's talk about the type of schedules. When it's come to types of schedules, one of the ways to look into the type of schedule classification is by scheduling method as well. Other ways for schedule classification can be activity types and project uses. The type of schedule used is directly related to the size, scope, and complexity of the project's planning, reporting, management, and controlling needs. Within the overall schedule, there may be a need to utilize other types of schedule, if required to address and convey critical aspects of the project. At key times in the life of a project, the type of schedule may change from one format to another, such as from a graphical presentation to a simple list of requirements or vice versa. Different schedules can and should sometimes be used within one project. Type of schedule based on schedule type/schedule model. Bar charts, sometimes referred to as Gantt charts. Critical path method, CPM. Arrow diagram method, ADM. Precedence diagram method, PDM. Type of schedule based on schedule type schedule model continued. Program evaluation and review technique, PERT. Linear schedule. Line of balance. Rolling wave. Milestone. List. Type of schedule based on activity types/project use. Milestones. Tasks. Hammocks and summaries. Level of effort, LOE. Type of schedule based on schedule type schedule model continued. Flags. WBS. Independent. Start. Finish. Baseline. Target. Control level. Fragmentary and work. Recovery. The activity is the fundamental work element of the schedule. The activity involves action. The activity should be uniquely identified with verb object, example, erect steel, prepare documentation, etc. The scheduler must understand each element of the scope of the activity and its related time. The schedule models the scope of work to be performed and is made up of activities, which reflect items of direct work or indirect work support. Each activity is an individual element of work that becomes logically linked to other activities to form the schedule. An activity has multiple components. Consider that an activity is the equivalent of a record in a database. Each record has multiple fields of data that define activity scope and characteristics for reporting and management of the work. The minimum components for an activity are a unique alphanumeric identifier, a unique descriptive name, optimally phrased as verb object, a duration. Individual activities have relationships and may have other attributes such as cost and resource loading. Constraints. The schedule activity is partly developed from the cost estimate model. The minimum and maximum allowable activity durations may be dictated by the scheduling specification. Logical linking of activities, together with contractual requirements and other constraints, form the schedule model. Level of detail in an activity must be appropriate for monitoring, managing, and reporting the project. That level of detail should be reviewed with concern to duration, complexity, execution methodology, cost, and risk. The activity must be in conformance with WBS, OBS, and CBS. The type of control level schedule may dictate the type or description of the activity. An activity is an individual element of work that is logically linked to other activities to form the schedule. Its primary characteristics include an overall duration based upon the resources applied to it, manpower, materials, and equipment, a start and completion date that is tied to a work calendar and has relationships to other activities, predecessor and successors. The level of detail must be appropriate for managing the project with concern to duration, complexity, methodology, cost, and risk. Duration is the overall estimated time in which an activity is planned to be completed. This becomes the original duration for activity and is an assigned element of the activity. Duration often includes multiple work elements within the activity scope. For example, the activity described as install concrete may include the following processes: forming, rebar installation, concrete placement, formwork stripping, and concrete curing. The schedule duration, in part, is derived from the cost estimate model and may be limited by the contract requirements or scheduling specifications. Estimates of detailed work element time intervals, along with understanding the usage, availability, and constraints of resources, are analyzed to calculate an activity's planned duration. A tried and true means of mathematically determining the duration. Duration, time, equals work quantity, units, divided by applied resources, units, or time. Duration increases with the amount of work of the activity, and it decreases with additional resources applied to the work. As the plan and schedule development evolve, activity durations are adjusted for better refined scope, resource utilization, location considerations, and demonstrated crew productivity. Relationship. The scheduling process requires that activities be logically linked to form a network schedule model. The network model is a representation of the project team's plan to accomplish the work in a mutually exclusive and interconnected manner, so that the program or project is brought to successful completion. Relationships provide a logical link or connection between two or more activities in a schedule. When a chain of activities of the longest duration are linked together, they define a critical path in a project schedule. Relationships between a series of activities form the schedule. Technically, the schedule is created when prospective dates are assigned to early or late start and finish events of the network. The simple logic network is the fundamental tool for building a schedule that reflects the plan for completing the project. Every activity must have a predecessor and a successor activity, with the exception of the first and last activities. The first activity will only have one or more successor activities. The last activity will have one or more predecessor activities. The project team should understand how various types of relationships affect the schedule model and the data that it reports. Nesting and grouping of activities is a functional part of scheduling and models how work is actually performed. At the time of developing the schedule model, the scheduler should understand how to transform an execution plan into a network schedule model. The schedule model must account for stakeholders and contractual needs and requirements. Understand how the use of various logic relationships, calendars, milestones, and hammocks are used to create a schedule model. The schedule model, in addition to meeting the stakeholder needs, must be able to accommodate change and change management. Understand how the different logic relationships or sequencing between activities and their lags have an effect on the schedule, critical path, and the work to be performed. As schedule activities are linked by relationships, the critical path is formed. Revising the logic and relationships between the various schedule activities may have an effect on the schedule and the critical path. Calendars. Calendars are sequences of actual time developed for functional purposes. Calendars may vary depending on the purpose for which the calendar is assigned. There may be multiple calendars contained within a project schedule model. Examples include Global 7-day. Workday. Resource. Weather, environmental and seasonal. Contractor or owner constrained. Calendars may have an impact on the calculation of the critical path, and the scheduler should be aware and understand how various scheduling software packages calculate dates, float, and the critical path based on the identified calendars and their input into the schedule. Project calendars are formulated to reflect specific events, long-running conditions, or circumstances associated with a project. A project calendar is assigned individually or globally to each activity, so that the duration of the activity may be allocated based on the characteristics of the calendar. Constraints include limitations and prescriptions for when events must or must not occur. Applying constraint affect the logic of a schedule model. Constraints may include resource limits or usage profiles. Constraints may take on many forms. Constraints are any factors that affect the start, finish, including intermittent progress, or duration of an activity. Factors may include, but are not limited to calendars, date restraints, and external such as resources, weather, or physical in nature. Constraints must be carefully considered and used only when appropriate. The scheduler should remember that application of any constraint will either a. extend the duration of the project, or b. have no effect on the project duration. Correspondingly, removal of any constraint will a. shorten the duration of the project, or b. have no effect on the project duration. Importantly, unnecessary or inappropriate constraints included in the network, or failure to include essential constraints, may create or define an artificial critical path and eliminate the true critical path. Constraints may have an impact on the calculation of the critical path, and the scheduler should understand how various scheduling software packages calculate dates, float, and the critical based on the constraints identified and input into the schedule. Combining activity durations, constraints, and calendars forms the underlying basis of a project schedule model. The resultant linking of the activities provides the identification of the multiple work paths through the schedule, as well as the critical and near-critical paths. Activity, calendar, and resource constraints will create discontinuous float paths. The path with the least total float value is called the critical or longest path. When analyzing near-critical paths, it is important to review how the constraints interact with schedule calculations to give false impressions of criticality. Cost and resource loading incorporates the activity cost estimate and the project execution plan into the schedule model. The WBS and OBS are fundamental elements used to assist in resource and cost loading. Cost and resource loading become the basis for resource leveling and scheduling the initial cash flow. Effective allocation of costs and resources imposes a fundamental, underlying requirement for successful project completion. The scheduler must understand how the various scheduling software programs load, allocate, and level cost and resources, as well as the potential impact the software leveling and calculation routines may have on the project schedule. Milestones. Milestones are intermediate or final events, control points that indicate certain goals or objectives have been achieved. Milestones may be contractual or may be functional, administrative elements of the schedule, but in all cases, they should be mutually agreed by the contractual parties and, perhaps, other stakeholders. The project team determines milestones, and the planner-scheduler incorporates them into the schedule. In some cases, milestones may be tied to contractual requirements. Milestones for a project may be an imposed or contractual requirement or an internal metric for the progress of the project in part or whole. Milestones are often related with bonus and penalty provisions in the contract. In all cases, schedule milestones should be agreed upon by all stakeholders prior to the approval of the project baseline schedule. Milestones have impact on a project schedule, including the development of the schedule. Schedule quality and compliance review. Schedule quality and compliance review should be a three-layered review process. It includes compliance with the contract, compliance with planned construction sequence of the works, compliance with accepted scheduling practices. Questions for schedule quality analysis include these. Is the critical path reasonable? Are there multiple critical paths, or could there be, if a few non-critical tasks are delayed? What activities are near critical? Does the work flow as planned? Are there space or safety conflicts between concurrent activities? Is there an excessive amount of work being done at any one time? Questions for schedule quality analysis include these. Continued. Are there resources enough to support all concurrent activities? Can subs and suppliers meet the schedule? Are any activities scheduled out of season? The schedule quality analysis and compliance review process is dynamic and interactive throughout the project. Effective use of the techniques is most important in the development phase of the schedule and remains relevant to all reviews and changes to the work. Schedule basis documentation. The baseline schedule provides the documentation and foundation for a schedule change or delays and impact identification and management. As such, it is important to create necessary documentation so that at a later date the schedule basis can be clearly understood by all. The baseline schedule documentation is recorded from the assumptions, constraints, and parameters as well as from the contract and supplementary documentation that goes into the development of the baseline schedule. Any changes in the schedule that result in significant variance from the baseline schedule can be traced to this document and the proper schedule adjustment developed and incorporated. The baseline schedule documentation includes a short narrative that describes baseline schedule development, the critical path, and key characteristics of the schedule model. Each stakeholder's input and assumptions are clearly identified. When it is necessary to develop a revised baseline schedule, the revised schedule must include the supporting documentation to support the changes made to the schedule. The schedule basis is contemporaneously updated throughout the life of the project.